So there were a couple of clues up in this text to help you figure out the name of the procedure that we are going to use. How many samples were taken? 1. 32 weather stations were randomly selected. So the sample is these 32 weather stations. What was collected from these weather stations? 2 peak temperatures. One from like 1960 to 2000, whatever's the highest, and then another one from 1900 to 1940. Says the differences were calculated for each station. And then over here it says the mean of the differences. So the average after subtracting. What do you guys think the name of this procedure is? One sample t-test for mu-diff, or you could call that same test what? A matched pairs. So you can call it matched pairs t-test for mu-diff, or a one sample t-test for mu-diff. I don't care which way you name it, both of those are considered acceptable. Whichever way helps you remember best. It did not say in the problem, what significance level should we choose? 0.05. When in doubt, 0.05. What is the symbol that we would use to represent the parameter here? Mu-diff. And what does mu-diff mean in the context of this problem? What'd you say? The true mean, the true average of the differences of peak annual temp, later minus earlier. Yes, true mean difference of peak temperatures. I did late 1900s minus early 1900s. You could say later temperature minus earlier temperature as they did in the problem. That would be perfectly fine. What is our statistic? X bar diff equals 0.35. What should our null hypothesis be? Mu diff equals 0. And that's the same as saying what? When we say mu diff equals 0, what are we saying in English about the situation? That there's no difference between earlier and later when we're looking at the averages overall. What would our alternative hypothesis be here? What'd you say? Yep. Mu diff is greater than 0. Absolutely correct. Do we have any evidence for Ha? What's our evidence? 0.35 is greater than 0. So you always, like, I already told you I'm not grading the evidence for Ha, but that does help you figure out the direction on your Ha if you're unsure of whether to write it as a less than or a greater than. What is your evidence showing? All right, so then we get into check. Do we get random? Yes, what did it say? 32 stations were randomly selected. And why do we care about random selection? To generalize the population. What's our population here? All weather stations. Yes, we want to generalize to all weather stations here. What's the difference between when we have random selection like this versus random assignment like yesterday? Yes, random assignment helps us determine causation. What if you have both? If you randomly select and then randomly assign? You could do both. You could generalize to the population and determine cause and effect. Do we have to bother checking 10%? Yes, because it is randomly selected. So what does our 10% condition look like? Yes. 32 is less than or equal to 0.10, or you could write 10% of all weather stations. And why do we care about this? So that we can sample without replacement. Why do we care about sampling without replacement? What does that affect? Independence. Do you guys remember back when we did probability? And we looked at certain situations where they weren't independent, like dealing out cards until you get the first king. The chance that you flip over a king on the first card is 4 out of 52. Assuming I don't get a king on that first flip, I flip over the next card. Now it's 4 out of 51. and then 4 out of 50. My probabilities keep changing. But as long as I have a large enough sample, the difference in those things is so minutely small that it doesn't realistically impact the probability of each selection. Normal large sample, do we get this? Yes, why? CLT. And what comparison do you need to make if you're going to use the CLT? Yes, compare it to 30. 32 is greater than or equal to 30. Central limit theorem. Why do we care about this? What did you say? So that what is approximately normal? What distribution? The population distribution? Yes, the X bar diff. We want the sampling distribution of X bar diff to be approximately normal. All right, calculate. General formula. Test statistic equals statistic minus parameter over standard error. So we have T equals X bar diff minus mu diff over S diff divided by square root of N. We have only one sample, so it uses the same formula as the one sample T test. So plugging in our numbers, I have 0.35 minus 0 in the numerator over 0.296 divided by square root of 32. You guys have this on your formula sheet in words. And you have this idea right here. It'll say S instead of S diff, but you have that on your formula sheet also. So you got to remember what is your statistic, what is your parameter, and then you can look at the formula sheet for how to calculate the standard error or standard deviation, depending on whether you're doing proportions or means. What did you guys get for the test statistic? 6.68, 6.69, same basic difference. And what are the degrees of freedom that we're using? 31 degrees of freedom, n minus 1. When we have one sample, even if it's a mu diff situation, one sample means degrees of freedom is n minus 1. What is this test statistic telling us? How many standard deviations we are away from the mean. What's the mean? 0. And so this is saying we are 6.69, more than 6.5 standard deviations away on the right. Before you even calculate this, what do you think that means for the probability for the p-value? Very small. Normally, we only go out how many standard deviations? 3 standard deviations on either side captures 99.7% of all the area under the curve. And we're talking about going out more than 6 standard deviations. So the p-value, 8.79 times 10 to the negative 8th. The calculator probably had notation that used an E. Remember that E stands for exponent. Don't put the E on your paper, whether it's a test for me or the AP exam. That's considered calculator speak and not proper mathematics. This, however, is considered proper mathematics, and this would receive credit for a correct p-value. What is this the same as in decimal form? Yeah, 7 zeros before we get to a number. So functionally, this is the same as a probability of what? Basically a probability of 0. It is so small that it is basically a probability of 0. And so would we reject or fail to reject? We would reject. So assuming the HO is true, mu diff equals 0, there's an 8.79 times 10 to the negative 8th probability of getting an X bar diff of 0.35 or more purely by chance. If you wrote this out in decimal form, that would be perfectly fine also, but pick one, either decimal form or scientific notation. And so there's our interpretation of P, and then decision and conclusion. Because 8.79 times 10 to the negative 8th is less than 0.05, we reject the null and have convincing evidence that peak temperatures increased in the 1900s, late 1900s minus early 1900s. One of the things I want to point out is sometimes when these numbers are in scientific notation, people aren't taking their time to do this comparison. They're just seeing the 8 and they're like, oh, 8 is bigger than 0.5. Remember that scientific notation, when you have a negative exponent, it has leading zeros after the decimal point. So as long as this is a number bigger than 2, so you have like -3 or -5 or -7, Because if I moved this 2 places to the left, that would be 5 times 10 to the negative 2. So far, so good? Give me a real quick thumbs up, middle, or down. How did you feel about this problem? Awesome. Fantastic. Let's flip the page over. We've talked about the 4C method a ton of times, so I'm not going to go over that again. But I do want to take a minute to touch on one sample or two. Is this a t-test for mu diff, or is this a t-test for mu1 minus mu2? When it's a t-test for mu diff, we have one sample that has paired information, but only one sample will be taken. You subtract first, all the pairings get subtracted, and then you find the average. This is the mean difference, the average of the differences. T-test for mu1 minus mu2, we have 2 distinct samples. 2 samples were taken and information was collected about each of those samples. You take the average of sample 1 and the average of sample 2 and then subtract. So you average first and then sample. This is the difference of the means, the difference, subtraction of the averages. I have found some examples down below to give us some practice determining whether we are looking at 2 sample T procedures or matched pairs T procedures. I want you guys to read through these 3 scenarios, decide whether you think it's a 2 sample T procedure or a matched pairs T procedure, and give some evidence from what you read. You don't have to quote the text, but you should be able to point to something in the text that you're like, I know this is only 1 sample, or I know this is 2 separate samples, here's what they are. Since there's 3, I'm going to give you guys 6 minutes. If we are all finished in less than 6 minutes, then we'll go over it sooner, but otherwise you guys have until 1:20 to do the check your understanding. All right, number 1, looking at this random sample of 30 adults that were selected. Each adult reports the number of pieces of junk mail and the number of pieces of junk email they received each day. Researcher would like to know if the adults received significantly more junk email than junk mail in their mailbox. Is this a 2 sample T procedures or a matched pairs T procedures? This is matched pairs, which would be the same as mu diff. So matched pairs would be the same as mu diff. What evidence do we have? There's only 1 sample. We have a random sample of 30 adults and no other samples are described here. So we have 1 sample of 30 adults and the 2 measurements are paired for each adult. The 2 measurements being junk email and junk mail. So only 1 sample was selected. 2 pieces of information were collected. All right, let's go look at number 2. Is number 2 a matched pairs T procedures or a 2 sample T procedures? 2 sample T procedures, which would be the same as mu1 minus mu2 or mu west coast minus east coast or mu something minus mu something else. What's our evidence for that? We have a random sample of 100 people that live on the West Coast and then a separate random sample of 100 people that live on the East Coast. So 2 independent samples here. What about the last one? The researcher with the 15 cell phones. Is this paired T procedures or mu1 minus mu2? This is paired. So the same as mu diff. What's our evidence for that? There's 1 SRS. We have an SRS of 15 cell phones. And then 2 pieces of information were measured and paired for each cell phone, Virginia minus Pennsylvania or Virginia and Pennsylvania. You could do Virginia minus Pennsylvania or Pennsylvania minus Virginia, but they're subtracting those differences, or those signal strengths there. All right. You guys have homework that is due tomorrow, and you've got 10 minutes of class time to work on that. So why don't you go ahead and pull that out unless you are finished with it. I am here to answer any questions that you might have or anything that is causing you confusion or frustration.